Hello.
Good afternoon.
Yeah, I can't see all of you. I don't know for what reason. Sanjay, are you the host? Hariharan, are you the host?
You're the host, ma'am.
I am the host, but I'm not able to share the screen. Okay, now I can. Okay, so only one participant is there. Where are the others? It shows 4 participants. Sai Kalyan, are you there? Sai Kalyan?
Yes, ma'am.
Yeah. And Sanjay, are you there?
Yes.
Sai Kalyan, please switch on your camera. I am not able to see you. Actually, just switch on for a moment.
Now can you
Yeah.
see me, ma'am?
Yeah, now I can see. And Sanjay, you also switch on your camera. You know, there's something different now. If your camera is not there, I don't see you at all. Okay. Today Vidisha seems to be absent. How was the test? How was the test? Hariharan, how was the test? Sai Kalyan, how was the test?
Kind of easy, ma'am.
And what about you, Hariharan? How did you find the test?
I'm getting it, ma'am.
How was the test?
Ma'am, I wasn't able to attend it, ma'am. I was actually out of station, ma'am.
Okay, that's why in the last class also I didn't see you.
Yes, ma'am.
Okay. And Sanjay, how did you find the test?
Well, even I did not do.
You did not do,
I was not
or
feeling, yes, ma'am. I was
so you
not
didn't
well for
attend?
like 3 to 4 days.
Okay. Okay, so in the last class, I don't know whether I should wait. Now it is 6:07. I will just start. So this is what we were doing in the last class, the osmotic pressure. Okay, so we had started with the osmotic pressure. So we talked about osmosis, how you can have X-osmosis and how you can have end osmosis. So when two solutions are separated by a semi-permeable membrane, right? This is what happens. So when they are separated by a semi-permeable membrane, the solvent starts moving from the dilute solution into towards the concentrated solution. So there is a pressure which develops on this side, and the pressure which you apply on the membrane to stop the dilute solution from entering into the concentrated solution, that is known as the osmotic pressure. So how do you calculate osmotic pressure is using this equation pi v is equal to nRT, and there are different ways by which we use this equation. Okay, so this is one question we did in the last class. Now today we have to do this another question. Now let us see how to do it. One more question just for the sake of revision, I am doing it. So if 1.71 grams of sugar is dissolved in 500 ml of an aqueous solution at 300 K, what will be the osmotic pressure of the solution? Now please do it, all of you. Pi is equal to NB into R into T by MB into volume in liters. Okay, so what are the values given to us? Not NB, sorry, WB. We are talking weight, talking of the weight. Okay, how will you do it? Vaishnavi, how are you?
Yes, ma'am, fine, ma'am. Sorry, ma'am, due
Yeah.
to internet connection.
No problem. If the internet is good, please switch on the camera, because without camera, I won't see any one of you. All those who are here, please switch on your camera. Madhavan, how are you?
I'm fine, ma'am.
Vaishnavi, how was the test?
Yes, ma'am, it was, uh,
It was okay. There were some questions which were difficult, I think.
yes, ma'am.
Okay, let me see. I haven't got the papers and I'll understand. If there is some problem in some concepts, we'll do that again. So we have to do this. Who will let me see who finds the answer quickly? What is the value of R? 0.0821. Temperature 300 Kelvin divided by 342 molar mass is given there into volume is in liters, 500 ml, so it's 0.5 liters.
Ma'am, is the answer 0.49?
49, let me also check, I have not done it. Somebody else also please try. No, you have made an error. That's not the correct answer. Correct answer is 0.2463 atmospheres.
Ma'am, I got the value, ma'am.
You got it? Very good. Vaishnavi, did you understand where you made the mistake?
Ma'am, I will check, ma'am. Ma'am, I guess I have done some calculation.
Yeah, it must be some calculation. This is the one which we had already done in the last class. Now we did this. Oh, I'm doing that. Okay, now this one. So osmotic pressure of the blood at 37 degrees Celsius is 7.65 atmosphere. How much glucose should be used per liter for an intravenous injection so that it is isotonic with blood? Do you understand what is isotonic? Which has same osmotic pressure as blood. Okay, so osmotic pressure is given. Now you have to prepare a solution. When you inject an intravenous injection, when you give an intravenous injection, you have to make sure that the concentration of the injection is such that its osmotic pressure is it's isotonic with blood. Because if you have a dilute solution or a concentrated solution, then there'll be a problem. So that's why we have to be very careful here. So, but anyway, we use the same formula. Pi is equal to you can use it easily using the formula CRT. Concentration, let us find out. First, the concentration in moles per liter. Okay, so let us find out C. So 7.65 is equal to C into 0.0821 into temperature is 37 plus 273. So that will be 300, isn't it? No, 310. So it into 310. So what will C be equal to? 7.65 divided by 0.0821 into 310. What did you get? Sai Kalyan, your fastest, tell me.
Miss, I'm getting something like 2888888 something.
28888. How did you do? Are you finding the value of C?
No, miss, I'm finding the value of N.
Okay,
I
okay.
used
That may be. So value of C, how much did you get?
the other formula, ma'am. I didn't go for this formula.
Okay, okay, okay. So this will be 0.3005. That is the number of moles. And if you know the number of moles, what is the molar mass of glucose you took, Sai Kalyan?
Miss, molar mass of glucose. Ma'am, in the nRT into V, there where we can take the glucose formula, ma'am. R I substituted as 0.0821.
See, it is not, it is not, okay. PV is equal to nRT. So you have found the number of moles of glucose.
Yes, ma'am.
Okay. Okay. So number of moles of glucose you got as 0.2888.
No, ma'am, 28888.
No, there is some mistake that you are making. Number of moles.
Ma'am, actually, it's a calculation error. It is 0.288 only.
0.288, no?
Yes, miss.
See here, which formula? I have written all of them here. Which formula? You use
The
this one?
Second
Second
formula.
formula. So you found the number of moles of glucose, isn't it?
Yes,
From
ma'am.
number of moles of glucose. See why I took CRT, because I want to find out the, okay, you can do that way also, no problem. You have to find the mass of glucose. So if I find the concentration in moles per liter, then I can find the mass of glucose. So what is, now what, by your method also answer should be 0.3, this one only. Why should you get 0.2888?
When I do, it is coming, ma'am.
What is the volume you took?
Volume, I took 1000.
Why did you take 1000? Volume is 1 liter, no? You have to take it in 1 liter.
Oh, sorry, ma'am. Sorry.
Okay, so this we found concentration in moles per liter. So once you know the number of moles, can you find out the mass? You can convert the moles into mass by multiplying by molar mass. What is the molar mass of glucose? Molar mass of glucose I have not given there. I'll tell you now. So molar mass of glucose is equal to 180 gram per mole, right? So you multiply this. So mass of glucose is equal to 0.3005 into 180.
Ma'am, can you show that formula page again? Because I joined late. Right. Ma'am, 2 minutes.
Mm.
Ma'am, that is pi or what you should call that symbol as?
Pi.
Pi, okay.
Now you got
Ma'am,
it, Sai Kalyan?
Yes, miss. Yes, miss.
Shall I move further now?
Yes, ma'am.
So this is the question we did. First, we found the concentration in moles per liter. Then we had to convert that concentration in moles per liter into the mass per liter. So first, then what we have to do, convert the number of moles into mass. So how will we do? Number of moles is equal to mass by molar mass. So what is mass equal to? Number of moles into molar mass. So what is the number of moles here? It is this many number of moles per liter. right? So number of moles is 0.3005. If I multiply by this, I will get 54 point something. Approximately 54 grams per liter. So you have to dissolve 54 grams per liter of glucose in order to get a intravenous injection, which is isotonic, which has the same atmospheric pressure as that of blood. Now the next question, shall I go to the next one? Sanjay, did you note down? Madhavan? Vaishnavi,
Yes,
did you
ma'am.
note? Vaishnavi?
Yes, ma'am. No, ma'am.
Have you noted down?
Yes, ma'am. Noted, ma'am.
Okay, now we'll do the next question. Five percent weight by weight solution of cane sugar is isotonic with 1% weight by weight solution of an unknown compound. Find the molecular weight of the unknown compound. Okay, now this is a slight variation. What is it that you know? Isotonic means the osmotic pressure of solution A is equal to supposing there are two solutions. This is solution A and this is solution B. So they are what? Isotonic. Isotonic means their osmotic pressure of both the solutions are same. So supposing osmotic pressure of solution A is equal to what? WB into R into T divided by, since molar mass has to be found, we have to use this formula, MB into volume weight by weight solution. So this is okay, this should not have been weight by weight, but you have to assume that the weight, it is the density of the solution is 1 gram per ml. So this is weight by volume. You have to assume that it is weight by volume, right? Take it as weight by volume, not weight by weight. Because one very important thing in both of them, in these calculations, one very important thing is that we are taking volume of the solution everywhere. It's weight by volume. So that's why I made a change there. It's weight by volume. I will correct it. Okay. So divide by volume in liters, right? And for the other solution, it is this, and this is WB by into R into T upon MB into VL. volume in liters. Now, if and I also know that osmotic pressure of A is equal to osmotic pressure of B. So whatever values you know, let us substitute those values. So here, this one will be equal to now 5% weight by weight. What does weight by volume? What does it mean? It means that if the volume of the solution is 100 ml, right? What is the mass of the solute? 5 grams. Okay. Weight by volume, 5% means 5 grams of the solution, 5 grams of solute present in 100 ml of solution. Okay, so let me put the values here. WB is 5, R into T. MB for cane sugar is 342. It is not given, but I'll tell you molar mass. MB for cane sugar is 342. Into VL, volume is 100. 100 by 1000, that is 0.1. 0.1. Okay. XB is equal to what? It is 1%. So 1 into R into T divided by MB, we don't know, we have to find out, into volume is again 0.1 liters. Did you understand what I am doing? Now XA is equal to XB. So this whole thing, XA is equal to XB, let us put the values. XA is equal to XB. Now substitute the values. So what is XA equal to? 5 into R into T divided by 342 into 0.1 is equal to 1 into R into T divided by MB into 0.1. Everything is same, which can be cancelled. So you cancel everything here.
Ma'am.
What did you get? 5 by 342 is equal to 1 by MB. So MB is equal to what? Tell me, Sai Kalyan. 340. Yeah. Did all of you understand? Hariharan.
I got 68.4.
Yeah, 68.4 is the correct. Hari Raghav, did you understand?
Yes, ma'am, understood.
Okay, okay, good. So now next question is a test for all of you. Okay, if you have understood, have you copied the answer? Now in 5 minutes, I'll give you 5 minutes. I will not say anything. I'll give you 5 minutes. You do a second question similar of this type. Okay, so tell me the answer. So next question. 10% aqueous solution of cane sugar is isotonic with 1.74 aqueous solution. Find the molecular weight of. It is isotonic with aqueous solution of urea. You have to find the molecular weight of urea. Molar mass of cane sugar is equal to 342 gram per mole. And all both the solutions are weight by volume.
Ma'am,
Hmm.
I
What
got
is your approx?
approximately 0.6.
Again, you are making a mistake somewhere. You are not converting it into liters. Answer is 60. Your answer is close, but it's only the decimal position you make. 100 ml, no? So you make it into 0.1 liter.
I did
Did
not
you?
point one, ma'am.
But answer should be 60. I will show you just now.
Okay, I'm checking. I'll check.
Hmm.
Now I'm getting 59.8.
Yes, that's correct. So molar mass of urea will come to 59.8 liters. Oh, gram per mole. Okay, so you can actually, what you can do is you can, for such questions, these are very common questions in the exam. So for such questions, you can make a formula of your own. If you can understand the steps and do it, nothing like it. But you can, if it is a percentage of aqueous solution, the concentration is given in weight percent, weight by volume percent, then you can use a formula like this. So here in this formula, what is happening? XA is equal to XB, V1 is equal to V2. So if I put these two things together, then it will be W1B into R into T by M1B into V1 is equal to W2B into R into T divided by M2B into V2. And V1 and V2 are same, so I can cancel all these things. So what is the formula I am left with? W1B by M1B is equal to W2B by M2B. All right, so you just have to substitute the values here. So what is the mass of first one? 10. 10, what is the molar mass of the first one? Cane sugar, 342. 10 by 342 is equal to 1.754 upon M2B. So simple. So what is M2B? M2B is equal to 342 into 1.754 divided by 10. That will come to 59.8 gram per mole. Did all of you get it? Did all of you understand how to do these questions? So these are the two types of questions that can be asked in for osmotic pressure. So osmotic pressure, all types of questions we have done. So now you have to practice all the questions from the textbook or from the worksheet that you get. Okay. Shall I move further? So this is a new formula. It is not a new formula that you have to learn by heart. It is derived from the formula which you already knew. So that's why sometimes if it is you know it, then you can do it quickly. That's why I did one, and I was just thinking that somebody should be able to do it without doing all the steps, taking only the last step here. Okay, so weight by molar mass by molar mass of one solute is same as mass by molar mass of the other one. Okay, because the number of moles, basically the number of moles is same. Okay, so now for the sake of revision, because for doing the next concept, I am doing this. No, not this one. Next question. This I don't have to do again. Okay. Now I want you to do this question. 2 grams of benzoic acid is dissolved in 25 grams of benzene, showing depression of freezing point equal to 1.62 Kelvin. Molar depression constant for benzene is given here. Find the molar mass of benzoic acid. Now do it, all of it. I will remind you of the formula. What is the formula? This is depression of freezing point. This one is depression of freezing point. So what is the formula? Delta TF. Who will tell me the formula? Delta TF is equal to KF into what? WB into 1000 divided by MB into WA. So if you know the data, you can see here, show the depression in freezing point. So TB is given 1.62 and KF is given 4.9. Somebody take the calculator and do it quickly. Mass of benzoic acid is given as 2 grams and this is 1000 divided by MB, which we have to find out, and WA 25 grams of benzene, that is 25 WA. Okay, who will find out the answer? MB is equal to
Ma'am, I have a doubt.
Yeah, tell me.
Ma'am, here you have to take WB as 2 and WA as 25. In the exam, how are we supposed to know that for benzoic acid we should take a numerator, for benzene take denominator?
See, this is 2 grams of benzoic acid is dissolved in 25 grams of benzene. So what is the solute? Benzoic acid. And what is the solute?
2 by
Huh?
25. 2
Yeah,
by
2 by.
2 by 25. Okay.
Okay. Did you get the answer? Approximately MB is equal to 240, approximately 242 gram per mole. So what did you find? The molar mass of benzoic acid is 242 gram per mole. Now you don't know as of now, but I can tell you benzoic acid is C6H5COOH. This is the formula for benzoic acid. Okay, this will be generally given to you. But when you get this question in the exam, by that time you would have done enough organic chemistry to know the formula of benzoic acid. Now this is the formula. If this is the formula of benzoic acid, can you tell me the molar mass of benzoic acid? It will be C, H and O. If you calculate, carbon is 7, hydrogen is 6 and oxygen is 2. So this into 12, this into 1 and this into 16. So 84 plus 6 plus 32. So the molar mass of benzoic acid is how much? 122 gram per mole, right? And what have we found? The molar mass of benzoic acid is 242 gram per mole. Okay, so it is almost double, isn't it? 122 into 2 is 244. So what we have calculated is almost double the actual molar mass. So that means something is wrong here, isn't it? Something which has happened while preparing the solution, something my experimental value does not match the actual value. So this is case 1. We have to find out why my experimental value is not matching the actual value. Okay. Now, the second question that I want you to do is this one. Calculate the molar mass of KCl if 74.5 grams is dissolved in 100 grams, has a boiling point of 101.4. Kf for water is 0.52. Okay, so for boiling point, what do we write? Delta TB is equal to KB into WB into 1000 divided by MB into WA. So TB we have to find out. So what is the boiling point of water? Tell me. Pure water, what is the boiling point? 100 degrees Celsius, isn't it? All of you are busy copying the question. Am I going too fast? So what is delta TB? T2 minus T1. So what is T2 which is given here? So T1 is boiling point of pure water. This is T2 minus T1. So if I subtract, what delta TB is equal to T2 minus T1. That is equal to T2 is given 101.4 minus 100. So that is equal to 1.04. So that is equal to 1.04. So now substitute the values. 1.04 is equal to 0.52 into WB is, this is a little error, children. Please make a correction. Please make a correction. This point position is not correct. It is 74.45. 7.45, not 74.5. 7.45. Okay, please make the correction. So it is 7.45 into 1000 divided by MV. We have to find out into WA, that is 100. Okay, so what will we get? This is cancelled. So MV is equal to 0.52 into 7.45 into 100 into 10 divided by 1.04. So this and this also will get cancelled. You will get 2. So it should come to 37 point something, I think. 7.45. 37.25. So what is MB? MB is the molar mass that you have experimentally calculated. It's the experimental molar mass. Now let us find out the molar mass, the theoretical molar mass of KCl, molar mass of KCl. Potassium is 39 and chlorine is 35.5. So you get it as 74.5 gram per mole. Right? Now what did you find here in this case? The experimental molar mass is half of the actual value. Okay, so what did we find? Experimental molar mass is equal to theoretical molar mass divided by 2, half of it. And the previous case, it was double. In the previous case, what was my experimental molar mass? Experimental molar mass was equal to theoretical molar mass into 2. Did you understand? So in both cases, my experimental values are wrong. Okay, so this is case number 1 and this is case number 2. Right, so in both these cases, what did we find? That our molar mass calculation is, what molar mass we have calculated is actually abnormal molar mass. There is something that is there in the way we have done our experiment. There's something that we have ignored while doing calculation, and that is why our answer is either becoming half or it is becoming double. Okay, so to understand that, we have to understand what we call want of factor. So that is the next topic that we are going to learn, and this is the want of factor. Okay, so first important thing that you have to learn here is two things I want to remind you. First important thing is the definition of colligative properties. Okay, what is the definition of colligative properties? This first thing is, these are properties of dilute solutions which depend on the number of particles. So what are colligative properties? Properties of dilute solutions which depend on the number of particles and not on the nature of particles, not on the nature of particles. All right. Now, what I mean, so number of particles, supposing I take 1 molar solution of 1m solution, okay, a concentration, I take a solution of urea, and I take a solution of glucose, and I take a solution of sucrose. These 3 I take, and for all of them, the concentration is 1 mole per liter. This is also 1 mole per liter. This is also 1 mole per liter. All have the same concentration. Then they will all have same colligative. They will show same elevation in boiling point, same depression in freezing point, and same osmotic pressure. Whether I take urea, glucose, or sucrose, it doesn't matter what it is, all of them will show the same value for colligative properties, right? And in such cases where I take compounds like glucose, sucrose, and urea, if I calculate their molar mass also, there will be no problem. You will get the correct molar mass in the calculation. Okay, because here the number of particles in these solution is the same. What is the number of particles? Do you know? What is the number of particles? This is just a general knowledge question. Number of particles in 1 mole of a solution. Just leave 1 mole of a solution. Number of particles in 1 mole is how many? You know, it is 6.02 into 10 raised to 23. So when I say 1 mole, I am talking of like talking about 1 dozen. Okay, so 1 dozen, if I say what is the number I mean? Sanjay, when I say Sanjay is there. Sanjay, are you there? Yeah, he's there. Sanjay, hello? Except Madhavan, everybody has switched off the camera. Hello, Sanjay, are you there? Vaishnavi, tell me. When I say number 1 dozen, how many particles? I say 1 dozen of atoms. How many atoms am I talking about?
12.
12. So similarly, when I say 1 mole, how many particles I am talking about? 6.023 into 10 raised to 23. 1 mole means that, right? So if I have 1 mole of urea, how many particles of urea I am talking about? 6.02 into 10 raised to 23 molecules of urea. When I say glucose, that many molecules of glucose. When I say sucrose, same number of molecules of sucrose, 6.02. So since all these solutions have same number of particles, that is why they will show same elevation in boiling point, same depression in freezing point, and so on, right? Now supposing I take 3 solutions, 1 molar solution, 1 molar solution of, I take a solution of NaCl. What is the concentration? 1 mole per liter. And then I take another solution of K2SO4, potassium sulfate. It is also 1 mole per liter. And I take AlCl3, right? It is also 1 mole per liter. Now, if you have understood what I was saying earlier, here also they have same concentration, 1 mole per liter, 1 mole per liter. 1. Now, if I check and find the colligative property or depression of freezing point, it will not be equal. All 3 of them will have different. Now, what has changed? In the previous case, I said all these here will have the same elevation in boiling point. But here, all of them will not have the same elevation in boiling point. Why? That is what we have to understand. Why? Because when I say 1 mole per liter of sodium chloride, the molecule, the moment I dissolve it in water, what does it do? It forms 1 mole of Na plus ions plus 1 mole of Cl minus ions. Right? So total number of ions is how many? 2 moles. Right? So colligative property will depend on the number of particles. Here number of particles are like 2 dozen, 2 moles of particles. Here how many are there? It will give 2 moles of K plus 1 mole of SO4 2 minus. So how many moles of particles will be there? 3 moles. Right? And in case of AlCl3, I have taken 1 mole per liter. But what is happening? It has 1 mole of aluminium ions plus 3 moles of Cl minus ions. So total how many moles are there? 4 moles of particles. 4 moles of particles. And I already told you what is colligative property. It doesn't matter whether it is sodium chloride molecule or sodium ions or chloride ion. It only depends on the number of mole, total number of particles. So total number of particles in a 1 mole solution of AlCl3 is 4 moles, equivalent to 4. This is equivalent to 3. This is equivalent to 2. So which will have maximum number of particles? Tell me. Which will have maximum number of particles? AlCl3 will have maximum number of particles, right? And whichever has more particles will show greater elevation in boiling point. Which has more particles will have greater elevation in boiling point. So which will have the maximum boiling point or the highest boiling point? AlCl3 solution will have higher boiling point than potassium sulfate solution, and that will have higher boiling point than sodium chloride solution. All have the same molarity, all have the same concentration. This is also 1 mole per liter, this is also 1 mole per liter, and this is also 1 mole per liter. But what is happening? This is ionizing to give 2 moles of ions, mole ions. This is giving 3 moles of ions. And this is giving this is giving 4, sorry. This is giving 4 moles of ions, this is giving 3, and this is giving 2 moles of ions. And if I take urea, and I take it 1 mole per liter, it will have only 1 mole of ions. Why? Because it does not ionize in solution. It does not ionize in solution. Okay, so what did you understand? If there is a solute which ionizes in solution, then we will have to take care of its ionization in order to get the correct answer. We will have to take care of that. So all the formulae that we use, we will have to add a factor by which our experimental value becomes correct and it becomes equal to the theoretical value. So to do that, let me show you the formula. This is all the formulae are here, right? So in this formula, this is the first one, second one, third one, fourth one, all the formulae are there. And in all these formulae, you see there is the molar mass here. It comes here. In the denominator, the molar mass of the solvent comes here. So if the colligative property is less, the molar mass is more. If the colligative property is more, the molar mass is less. Okay. So to correct it, what we do is we multiply it by what you call a Van 't Hoff factor. Okay. So the Van 't Hoff factor, if I multiply it by I here, it is called, you multiply it by I and you will get the correct answer. Okay. What is I? I is known as the Van 't Hoff factor. Okay. So let me explain.
Ma'am,
Hmm.
this I is as you said in the last sum, this I is basically a relation between the theoretical molar mass and the practical molar mass.
Yes. So what
This
is I?
the
Yes,
amount of factor, miss, I have a doubt. This I is by practical molar mass by theoretical molar mass or theoretical molar mass by practical molar mass?
that is what I am going to explain now. Okay. Just note down with I. Shall I take the next slide? You leave this part, children. Right now you leave this. I'll explain that second part after this. Okay. So I have put in a factor I, which is called the Van 't Hoff factor. It is. So this I can be calculated in a number of ways. Okay, so I is equal to, it can be, I can call it normal molar mass. First thing which Sai Kalyan pointed out, we'll take that only, normal molar mass divided by abnormal molar mass. Molar mass. Okay, so there are two questions. Case one. Okay, what was the
Here
yeah.
the normal mass is that we calculated only, no ma'am.
Yeah. Normal molar mass is theoretical.
Okay, miss.
You can call it theoretical molar mass
Miss,
divided by calculated.
Miss, theoretical means
Or no,
according
theoretical
to,
divided by experimental. That is what you write. You will not get confused. Experiment. So the one which you have calculated by experiment and the one which is theoretical molar. So in case one, what is happening? In case one, my theoretical molar mass was 122. And the one which I calculated was 240, which I experimentally found was 240, almost 242. So what was the value of I? I was equal to 0.5. In case 2, what was it? In case 2, my normal molar mass was, theoretical molar mass was 74.5. And what did I calculate? Calculate 37.25. So what was I equal to? I was equal to 2. Okay, there is one more way of calculating it. Now, if I look at case 1, what was my solute in case 1? It was benzoic acid. Right? And in case 2, what
Ma'am,
was
I have
my...
a doubt, ma'am. Ma'am, in the previous slide, you showed that you had that factor right to correct those things.
Yeah.
In order to correct what?
What?
In order to correct what we are adding that I factor.
We are correct in order to correct the molar mass. See in the previous, okay. So the molar mass that we calculated was 242. So if I had multiplied it by 0.5 in the beginning, I would have got 122, isn't it? So then I would have got the correct value. Okay. So here I2. So if in this case I got the double value of molar mass, if I had multiplied by 2, I got half the value. So I would have if I had multiplied by 2, I would have got 74.5. All right. Now in this case, my solute was benzoic acid. And in this case, what was my solute? Potassium chloride. Okay. So probably what has happened is, why my value of I comes to 2? Because my potassium chloride dissociates into 2 ions, 2. All right. It dissociates completely into 2 ions. So value of I is 2. Now here, in case of benzoic acid, what is happening? In case of benzoic acid is like the C6H5, C double bond O and OH. This is the formula of benzoic acid. And this is another formula, another molecule of benzoic acid. If I draw it here, this is another molecule. I don't know, in 11th standard, have you learned hydrogen bonding? Anybody? Sai Kalyan, Vaishnavi, have you heard of hydrogen bonding? So hydrogen bonding is an intermolecular force of attraction which exists between several molecules, especially when hydrogen is attached to oxygen. So there is hydrogen bonding between two molecules of benzoic acid, and the two molecules of benzoic acid, they behave like one molecule, right? Here one molecule is behaving like two because it is breaking into two ions. Here two molecules are behaving like one. So what is here one is behaving like two, and here two is behaving like one. So colligative property, here I is 0.5 and here I is 2. So there we can derive another formula here. What is the second formula for finding the value of I? I can be the number of total number of particles, total number of particles after dissociation or association divided by total number of particles before dissociation. Or after or association. All right. So like in case of potassium, like in case of aluminium chloride. Okay. And this will give Al3 plus 3Cl minus. Okay. I forgot to change the color of the ink. Okay. So what is the total number of particles after? So what is the value of I if your solute is AlCl3? What is the value of I? Number of particles after dissociation, 1 plus 3, 4. And what is the number of particles before dissociation? 1. So I is equal to 4. All right. In case of benzoic acid, any organic acid, in case of benzoic acid, how will we make a calculation? CH2 molecules of CH3COOH are combining to form one molecule of not CH3. Let us make it acetic acid. Okay, so two molecules of acetic acid are combining to form one molecule of CH3COOH. So number of what is the value of I? I will be number of particles after dissociation, 0.5. Number of particles before dissociation, 1. Right? Or I should write here not like this. It is number of particles after dissociation is 1 and number of particles before dissociation is 2. So answer is 0.5. Okay, so this is a factor which you will have to introduce to all your formula in case your solute is associating or dissociating. In case of glucose, fructose, urea, etc., which are organic molecules which do not dissociate or associate, there the value of I is equal to 1. I is equal to 1 because total number of particles after dissociation is 1 and before dissociation is also 1. So it doesn't matter whether you put I there or not. But if it is associating or dissociating, then you have to put that Van 't Hoff factor there to get the answer correctly. Okay. Now let us do one question. Okay. So did you understand about Van 't Hoff factor? Now there is a little bit more remaining. Then we will almost finish this chapter. So now sometimes what happens is that the number of particles before dissociation and association, it is very easy to calculate the value of I, because you know the acids will associate, the what you call the other ones, they will, the ionic compound, they will dissociate. So it is very easy. If they dissociate, calculate the number of particles and you can find out the value of I, put it there and find the answer. But sometimes what happens is that the solutions are such which will not dissociate completely. Like supposing I take sodium chloride solution. If it dissociates completely, then it will give you Na plus Cl minus, right? Now, supposing it does not dissociate completely. So I will write here, leave a little space, plus Cl minus. So supposing I take 1 mole per liter of sodium chloride, it should dissociate into sodium chloride, all sodium chloride and sodium and chloride ion, but this time dissociation is not happening completely. So out of 1 mole of particles, only alpha particles dissociate. Only alpha particles dissociate. So how many sodium ions will form? Only alpha sodium ions and alpha chloride ions will form. Did you understand? So, so
Can you repeat?
see, what I am saying is that when we are doing the calculation, which I told you, I is equal to number of particles before dissociation and after dissociation, before dissociation, I was assuming that all the sodium chloride will completely dissociate. Okay, so if I assume complete dissociation, so supposing I assume complete dissociation, so supposing I had 1 mole per liter of sodium chloride, it dissociates completely. How many sodium ions will it give? 1 mole. And how many chloride ions it will give? 1 mole, right? Complete dissociation. Now what I am saying is, it's not necessary that it dissociates completely. Sometimes it may not dissociate completely. So I took sodium chloride, it dissociated into sodium and chloride ions, but not completely. So I took 1 mole per liter, and out of that 1 mole per liter, only some part of it dissociated. So how much dissociated? Let us assume alpha dissociated, right? And if alpha dissociated, then only alpha sodium ions and alpha chloride ions will be formed. Okay. So how will we find I? I is equal to number of particles after dissociation divided by number of particles before dissociation. Right? So in this case, I will be equal to, what will be the number of particles after dissociation? 1 minus alpha plus alpha plus alpha. Total number 1 minus alpha plus alpha plus alpha. That will be the total, divided by 1. So it will be equal to 1 minus alpha. I will be equal to 1 minus alpha. Okay. Supposing I take magnesium chloride. So supposing I take another compound, magnesium chloride, right? It should ionize to give you Mg2 plus 2 Cl minus. So if I take 1 mole of magnesium chloride and out of that alpha dissociates, So when alpha dissociates, how many magnesium ions will I get? Alpha. And how many chloride ions I will get? 2 alpha. Right? So what will I be equal to? I will be equal to 1 minus alpha plus alpha plus 2 alpha by 1. So alpha will be equal to 1. In the previous one, what did we do? This is a mistake here, no? This is plus 1 plus alpha. Here it will be 1 plus this and this will get cancelled, 1 plus 2 alpha. I is equal to 1 plus 2 alpha, right? So there is for each compound, there could be a different degree of dissociation. Now from this equation itself, you can understand what I am trying to say, that if the compound is completely ionized, that means alpha is, all the particles are ionized, right? Then what is alpha? Alpha is equal to 1. All the particles are completely ionized. So 1 out of 1, 100% ionized, right? 100% means 1 out of 1, all are ionized. Then what will be the value of I? Value of I is equal to, will be 1 plus 2, that is equal to 3. That's the same thing I told you, number of ions. But if it is not completely ionized, then you will have to use this formula, I is equal to 1 plus 2 alpha. Now, all the time, it may not be possible to use this formula, write down and use the formula. So sometimes it is easier to use a formula which is well known, it is derived in a particular way. And the formula is that alpha is equal to I minus 1 upon n minus 1. Where n is, so I you know, alpha is you know, where n is equal to number of particles after dissociation. Theoretically, after dissociation. Okay, so we can use this formula, alpha is equal to I minus 1 upon n minus 1. Now let us do one question, then only you will understand what I am talking about. A decimolar solution of NaCl exerts osmotic pressure of 4.6 at 300 Kelvin. Calculate the degree of dissociation. Okay, decimolar solution means the concentration of the solution C is equal to 0.1 moles per liter. Deci means 1 by 10. So 1 by 10 moles per liter or 0.1 moles per liter. So let us find the osmotic pressure. So pi is equal to I into, now it is sodium chloride solutions, we have to put the value of I. So I into C into R into T. So that is equal to I is NaCl, it is 2. We are assuming that it is completely ion. No, we have to find I, sorry. Pressure is given. So 4.6 I into C is given 0.1 into 0.0821 into temperature 300. So what is I equal to? People who are fast, quickly find out. Did you get 1.86? Okay. For NaCl, we had found out what is I. I is equal to 1 plus alpha. Right. So what is alpha? Degree of dissociation is alpha. So how will we calculate alpha? 1.86 is equal to 1 plus alpha. So alpha is equal to 0.86. The formula that I gave you is also will tell you the same thing. Alpha is equal to I minus 1 upon N minus 1. So alpha is equal to I, that is 1.86 minus 1 upon N is equal to 2 minus 1. So that is also 0.8. So whichever way you like, you can do. So this is 0.86. What is the meaning of this? That degree of dissociation is 86%. Above 0.86. That means degree of dissociation is 86%. Out of 1.86, out of 1 mole of one particle, only 0.86 has dissociated. So degree of dissociation is 86%. So what does it mean actually? If I had 100 molecules of sodium chloride, excuse me, if I had 100 molecules of sodium chloride, only 86 molecules dissociated into sodium and chloride ions. The remaining 14 molecules did not dissociate. If all of them had dissociated, what would be the value of I? Then the value of I would have been 2. It was not 2, it is less than 2. What is the value of I? 1.86. Why is the value of I less? Because it is not completely dissociated. And that is why we are calculating the degree of dissociation. If the degree of dissociation was 100%, then the value of I would have been 2. Since the degree of dissociation is only 86%, then the value of I is less than 2, that is 1.86. Now I want all of you to read it from your textbook. Now in tomorrow's class, I'm going to finish. In the tomorrow's class, we will finish this chapter. All important concepts we have done. I'll only do some extra numericals because we have done where the value of I is more than 1. Now we will do the one where there is association. So we did not do want-off factor of association. So that calculations also we will do. And then we will learn how to find the dissociation constant of acids. So that we'll do in tomorrow's class. So please read the textbook properly and come. Now, before I close, have you all noted down? Shall I stop sharing?
No,
Yeah.
1 minute. Ma'am.
All of you, please switch on the camera. All of you, please switch on the camera because I can see only Madhavan now. There are 6 more. Yeah. So tell me.
Ma'am, my Wi-Fi is bad.
Okay, never mind. If your Wi-Fi is bad, I can understand. Who all are there? So Vaishnavi, have you understood everything?
Yes, ma'am.
You are muted. I can't hear you.
Ma'am, can you come again, ma'am? It was breaking for me.
Yeah. So you have understood? Hari Raghav, did you understand?
Ma'am, yes.
Yes. So now I want all of you to take the textbook and start doing all the questions from behind the text. So in tomorrow's class, I want to clear your doubts. Whatever doubts you have, whatever things you have not understood, I want to go through that again. Okay. So I will do a few questions and then last half an hour is only for doubt clearing. Okay. So please ask all your doubts and then we can continue with the next chapter. Okay. So see you tomorrow. Bye.
Thank you, ma'am.
Thank you, ma'am.
Thank you.